Hi, this video is an example of a subtraction of rational expressions. Now remember, whenever we add or subtract, we have to come up with a common denominator. We do that by finding the least common denominator of all terms. In this case, I'm going to find the least common denominator of 12 plus x minus x squared and x squared minus 9. The first thing I want to do is see if I can factor these denominators. Here I have a minus x squared, so I'm going to actually pull the negative sign out to make factoring easier and have x squared minus x minus 12. Now, whenever we pull out a negative sign, the easiest thing to do with that is to simply move it on up. Or in other words, I'm just going to take my negative sign and move it to the numerator. So now instead of a 3, I'm going to have a minus 3. And now for my denominator, I'm going to factor x squared minus x minus 12. I'm looking for paired multiples of negative 12 that sum to negative 1. So in that case, it's going to be x minus 4, x plus 3. All right. For my second term, I have x squared minus 9. This looks a lot like Mr. Formula. Notice I have a perfect square of x squared is x squared, and a perfect square of 3. 3 squared is 9. And I'm subtracting them. So Mr. Formula does hold, and this will actually factor into x minus 3, x plus 3. So that is going to be my second term. Minus 2 over x minus 3, x plus 3. Now let's look at what our common denominator will be. All right. We're looking for the least common multiple of my two denominators. So in other words, I'm looking for the least common multiple of x minus 4 times x plus 3 and x minus 3 times x plus 3. All right, so first let's look at x plus 3. I see that it occurs in both, but it occurs at most once, so that's going to be part of my least common multiple. I have x minus 4 that occurs once, so I'm going to list it once. And I have an x minus 3 that occurs at most once, so I'm going to list it once. So this is my common denominator. Okay, so first I'm going to convert this first term in terms of my common denominator. Okay, and now I want to get that in terms of x plus 3, x minus 4, and x minus 3. Well, the only thing my denominator is missing is the x minus 3, so I need to put that in the numerator. Okay, so whatever I multiply the denominator by, I have to multiply the numerator by. So I get minus 3 x minus 3. And now if I want to, I can go ahead and distribute that negative 3 out and get minus 3x distributed again plus 9. Okay, so that's my first term. My next term is 2 over x minus 3, x plus 3. And I want to get that in terms of my common denominator, which is x plus 3, x minus 4, x minus 3. Once again, I observe my denominator, to determine what it's missing. So in this case, my denominator is missing the x minus 4 term. So I need to multiply my denominator by x minus 4, and whatever I do in the denominator, I have to do in the numerator. So this becomes 2 times x minus 4. And now again, I can go ahead and distribute this 2, all right, and I get 2x minus 8. Now I have each of my terms in terms of my common denominator, so I'm ready to rewrite this problem. I have minus 3x plus 9 over x minus 4, x plus 3, x minus 3. And then look, remember, you're subtracting 2x minus 8 over the same denominator, x minus 4, x plus 3, x minus 3. Okay. And now, remember, whenever I add and subtract, I'm going to keep my denominator. So that's going to stay exactly the same. X minus 4, x plus 3, x minus 3. And I'm going to perform the operation in my numerator. The tricky part about subtraction is that I have to make sure that this negative sign is distributed to every term in the numerator. Okay? So my answer is going to become minus 3x plus 9. But now I have to distribute this negative sign. So I'm going to have minus 2x, okay, because a negative times 2x gives me a minus 2x. And then I have to also distribute it to the 8. So I'm going to have plus 8. Now combining like terms, my final answer would be in the numerator I have a minus 3x and a minus 2x. So I get a minus 5x. I have a 9 and an 8 positive, so they're going to leave me 17. And my denominator is just going to be the same. Remember, we perform the operation in the numerator, keep the denominator. So x minus 4, x plus 3, x minus 3. Again, this was an example of subtracting a rational expression. So you're going to have a subtraction sign here. And remember, the key to getting these correct is when you get ready to subtract your second term, you need to make sure that you distribute the negative sign to everything in that term.